Moving on to, well, not moving on, staying in 1.3, finishing that up today. We're going to look at two more properties of real numbers today. Like I said, it should be pretty quick, so let's get after it. An easy way to find the sum or product of numbers is to group or associate the numbers using the associative property. I'll kind of expand on that whenever we get to a problem where we have to associate. But we usually use parentheses to group or associate numbers together. Okay? So our first property is the associative property today. The second property we're going to talk about is the commutative property. For the addition and multiplication of real numbers, the order does not change their sum or product. This is called the commutative property. So in an addition problem or a multiplication problem, I can move numbers around. It does not matter which number comes first or last. The order does not matter. I'm going to get the same answer every single time. You okay with those two things? The next slide talks about these two things as well. So I'm going to go to that slide. It just kind of puts it into words, symbols, and examples for us, just like our yesterday's properties did. So the associative property, the way you group three or more numbers when adding or multiplying, does not change their sum or product. So, some examples here. Here I've got 2 plus 9 plus 4. So what I could do is I could group or associate the first two numbers together first, meaning that I would add those two first, correct? And then I would add 4 to that result. That's going to give me the same result as if I group 9 and 4 together and add those first and then add 2 to it. Does not matter which ones I associate together, but I can associate numbers together to add first and then add the rest to it.
So it would be like associative property just getting the same thing. Both would be the same. Like
Yeah. So in this case, 2 plus 9 would give me 11. And 11 plus 4 would give me 15. Over here, 9 plus 4 would give me 13. 13 plus 2 would give me 15. Do we get the same result? Yep, we do. So, associative property tells me that I could group sets of numbers together to add first. And I'll explain more, but there's some problems on our notes where it's very beneficial for us to associate two numbers together because it makes our addition easier. Okay? It's kind of the purpose behind it. Same thing works for multiplication. I can group, so down here I got 3 times 6 times 5, so I could group or associate 3 times 6 together first and then multiply 5, or I could associate or group 6 times 5 together and then multiply by 3. Either way, I'm going to get the same result. Any questions about the associative property? Okay. Commutative property. The order in which you add or multiply numbers does not change their sum or product. So this just essentially means that I can move numbers around in a problem if it's addition or multiplication. Does everyone agree that 8 plus 12 is going to give me the same result as 12 plus 8? The order does not matter in which I have it. It also works if I have more than two numbers. 3 plus 4 plus 5 plus 6 is going to equal the same thing as if I did 4 plus 5 plus 6 plus 3. The order in which the numbers are added together does not matter. That's what the commutative property tells me. Same thing goes for multiplication. 4 times 9 is going to give me the same thing as 9 times 4. 2 times 3 times 4 is going to give me the same result as 4 times 3 times 2. The order in which it is written does not matter. Any questions about our commutative property? So associative property, I can group numbers together or associate them together with parentheses. Commutative property, the order in which my addition or multiplication problem is written does not matter. Questions on those two? Can I move on? Okay. Jalen wants to add up how much money he spent on gasoline in the month of July. He grabs the 4 receipts he has for July and writes the expression that represents the total amount he spent. Evaluate the expression to determine how much Jalen spent on gasoline in July. So let's go ahead and write our expression first. If I want to find the grand total of how much he spent on gas in July, what would I do with all these totals? Add them up, right? To find the grand total, I just add up all my other totals. So we've got $34.50 plus $32.50 plus $23.25 plus $31.75. So there's my expression to find out how much Jalen's going to spend total on gas in the month of July. We okay with how we got the expression? Okay. Do any of these numbers look like they're going to be easier to add to one thing than the other? Give me some thoughts here.
34.50 plus 20 at 32.50.
Why do you think those would be easier to add?
Because the cents are the same.
Yeah, the cents are the same. If I add 50 cents and 50 cents together, that's going to give me what? $1. So if I add these first two things together, or I associate them together, or group them together, using our associative property, it's going to give me a nice even dollar amount. Does everyone recognize that? Okay. What about these two numbers?
You get an even dollar amount.
Same thing, right? I can associate these last two numbers together. When I add those together, 25 cents plus 75 cents, that's going to give me a nice even dollar amount as well. Does everyone recognize that? So in this case, it's really nice and really beneficial for us to associate or group certain sums together to make it easier on ourselves when we're adding. Does that make sense? Okay. So that's kind of the basis or the purpose behind the associative property. Sometimes it makes our lives easier. Okay. $34.50 plus $32.50 would give me what? About $6, $7, right? 6, 7. Everyone good with that? 34 plus 32 gave me the 66, plus the extra dollar from the 50 cents plus 50 cents gave me the 6, 7. Everyone good with that? I brought this plus sign down. That's between my two parentheses. $23.25 plus $31.75 gives me what? What? $55. 23 plus 31 gave me the 54. 25 cents plus 75 cents gave me the extra dollar to give me 55. And now we have two nice, really clean whole dollar amounts. Everyone good with that? I would much rather add whole dollar amounts than some dollars and some change, right? So that made our lives a lot easier. Now I can easily add 67 plus 55. What does that give me? So in total, Jalen spent $122 even on gas in the month of July. Any questions on how we use the associative property here to help make our lives a little bit easier when finding this total? No. Good? Yes. Perfect. Can I move on? Yes. Evaluate 5 over 6 times 9 times 6 over 5. 5/6 times 9 times 6/5. Seeing this problem, what are some of y'all's initial thoughts? They're what?
Inverse.
Yeah, they're multiplicative inverses or reciprocals of each other. I like where we're going with this.
Those just be 1.
Yeah.
Times 1.
If I multiply a number by its reciprocal, we learned yesterday, based on the multiplicative inverse property, that the result is 1, correct? Right now, they're not written by each other, though. So how could I fix that? Huh? Yeah, what property tells me I could do that? Commutative property, right? The commutative property tells me that the order in which I'm multiplying or adding does not matter, correct? So I'm going to rewrite this expression to have my two reciprocals be by each other in the multiplication problem. Based on our commutative property, I'm able to do this. Questions about what I've done? Okay, like we said here, based on our multiplicative inverse property from yesterday, I've got a number being multiplied by its reciprocal here. A number times its reciprocal will always give me a result of what? 1. And that makes our problem 10 times easier, I would say. Everyone good with that? Okay. 1 times 9 gives me 9. What property is that from yesterday?
Multiplicative identity.
Perfect. Multiplicative identity. Anytime I multiply a number by 1, I get that number back. Look at us using all our properties. Look at us go. So proud of y'all. Questions on example 8? Everyone see all our properties at play here. Okay. Can I move on to my last example? All right. This is very similar to our gasoline example. Jade buys groceries once each week, and she wants to calculate how much she spent on groceries over a 4-week period. Evaluate the expression to find out how much Jade spent at the grocery store. So, if I want to find her grand total over the 4 weeks, what do I do with all these totals I have over to the right? What? Add them up. 32 plus 27 plus 28 plus 33. Everyone good with that? To find the grand total she spent over the 4 weeks, I add up all her grocery bills from those 4 weeks. Questions there? Okay. Let's think about our properties that we've learned about today, commutative and associative. Are there any numbers that might be easier to add together here?
33 and 32 and 28 and 27.
33 and 28.
That's the more route that I was thinking. 32 and 28 would give me a number that ends in what? 0, which I usually like to deal with numbers that end in 0. They're usually pretty easy to add, right? And 27 and 33 will also give me a number that ends in 0. It's going to be pretty easy to add two numbers that end in 0, in my opinion. If you like to get numbers that end in 5, what you said would be fine. Okay? We could add 27 and 28 and 32 and 33 if you wanted to go that route. Okay? What property did I just use? Commutative. I moved numbers around. I moved the order of the numbers around in the problem. Does that make sense? Based on the commutative property, I'm able to do that. Now, we said 32 and 28 we need to add together. So I'm going to use what property to group them? Associative. Yep. I'm going to use the associative property to group these two numbers together, because I know that I would like to have a number that ends in 0. And I'm going to group 27 and 33 together, or associate them together, because that will also give me a number that ends in 0. I'm going to go with those 2 steps that I've done so far. Now, let's add them up. 32 plus 28 gives me 60. 27 plus 33 gives me also 60. Like we said, associating those numbers together gave me 2 numbers that end in 0, which is a lot easier to add in my opinion. 60 plus 60 gives me 120. Jade spent $120 on groceries in 4 weeks. It's really impressive. That's really cheap. Questions on example 9. We were able to use our commutative property here and our associative property within the same problem. We good? All right. Bless you. Here's your assignment for today. 1.3, homework number 2, MH. When's the due date for this assignment? 2 school days from now, which is not Tuesday. Wednesday. You guys are out of school on Monday, so this is due on Wednesday for you guys. So you can go ahead and start getting your iPads out to get started on it. If you did not finish yesterday's assignment, I would probably focus on that first, since that one is due Tuesday. Does that make sense? Any questions, comments, concerns about the notes before I end the recording? Perfect.